Good day, STEM students. Welcome back to Mampaisan's online classroom. Today, we're going to have the Newton's Law of Universal Gravitation Part. During the last video, we already discussed Newton's Law of Universal Gravitation as well as acceleration due to gravity on different planets. This time, we're going to discuss escape velocity and the importance of space exploration. Let's start. You see here a picture of Jupiter with sunglasses. Sabi dito, for space exploration, what is the major disadvantage brought by gravity? So that's one of the questions we're going to answer today. And then another question would be, how can gravity be overcome given that it provides potential gravitational energy to any object on Earth? Know that, di ba dun sa dati nating lesson about work, power, and energy, our reference point is the ground. So whenever an object is on the ground, it has zero gravitational potential energy. However, we're going to change that notion because always remember when we say potential energy, it has something to do with your possession. So if we change the reference point, the definition of or the amount of gravitational force, um, or the amount of gravitational potential energy pala that an object has also changes. So katulad dun sa dati nating um, lesson, nagkaroon na siya ng gravitational attraction relative sa center of the Earth. So ganun din dito, ang magiging reference point din natin is the center of the Earth instead of the ground. Okay, so relative to the center of mass of the Earth, everything on the surface of the Earth has gravitational potential energy. Okay, now let's discuss the escape velocity. Yan. Relative to the Earth's center of mass, this stationary rocket has a GPE or a gravitational potential energy that is greater than zero. As I was saying a while ago, potential energy is an energy that is because of an object's position. So let's say that this rocket is on the surface of the Earth. This is the Earth, let's say, and then this one is the center. Thus, let's say that the rocket is here. Rocket, or na lang, kasi I can't draw, I'm so sorry. Relative to the center of mass of the Earth, this one has a non-zero gravitational potential energy. Okay? Relative yan sa center ng ating Earth. Pero katulad nga ng nasabi natin dati, kapag relative to the ground, zero yung kanyang gravitational potential energy. But again and again, we change the reference point so that this thing would be true. And then, this GPE or gravitational potential energy must be overcome for the rocket to move towards outer space because of the gravitational pull of the Earth on the rocket. The rocket now possesses gravitational potential energy, and this energy hinders the rocket from escaping the gravitational pull of the Earth. So, kailangan yun yung ma-overcome natin. Gravitational potential energy. Paano? How do we overcome the gravitational potential energy? To overcome the GPE, KE, or kinetic energy that is greater than the gravitational potential energy must be supplied to the rocket. So, we know naman that kinetic energy involves movement, meaning kailangan nating pagalawin ang rocket na ito in such a way that the movement of this rocket would create or transform its gravitational potential energy into kinetic energy. The minimum kinetic energy to be supplied on the rocket must be based on what we call its escape velocity. We know naman that, again, kinetic energy is an energy associated with motion. And remember from our study of work, power, and energy, kinetic energy is equal to 1/2 mv squared, where v is the velocity of the object. So here, si rocket natin, kailangan natin siyang providean ng kinetic energy in such a way that it will move at a minimum velocity called escape velocity. The escape velocity of any object on the surface of the Earth is dependent upon two factors only. The mass of the planet. Wait lang, baguhin natin ang color. Let's turn it into yellow. Ayan. Again, the escape velocity of an object on the surface of the Earth, or let's say this rocket, is dependent upon two factors only. It does not depend on the mass of the object. Okay? Saan lang siya nakadepende? Depends on the mass of the planet and the radius of the planet. So to get the escape velocity, we just divide, I we multiply 2, and then the universal gravitational constant, and then the mass of the planet, and all of that we divide by the radius of the planet, and we get the square root of it. Let's define each variable here. The V escape is our VESC. VESC, alam naman natin in the computer when we pindot the ESC, that's escape, no? Shortcut for escape, okay? That's the representation for our escape velocity. And then nakita na natin dati itong MP, which is the mass of the planet, and then the RP is the radius of the planet. Says here that escape velocity is the minimum speed needed for a free, non-propelled object to escape from the gravitational influence of a massive object or massive body. In this case, the massive bodies that we're going to talk about are the planets. That is to achieve an infinite distance from it. We know naman that when something escapes the gravitational pull of the Earth, it will go, kasi sa outer space ay walang um, air particles, or very, very small amount of air particles lang ang meron. It's considered as a vacuum. In vacuum, an object that is moving will continue moving in the same speed, in the same direction, unless mabangga siya somewhere. So dito, once na na-providean mo na si rocket ng escape velocity, ng enough kinetic energy, may escape na niya yung gravitational influence of the massive body, itong Earth. Tapos, ang mangyayari sa kanya, the object will behave in such a way that it will move endlessly sa outer space hanggang sa may mabangga siya. So, pag may nabangga siya, it's either didikit siya dun sa nabangga niya or mag-iiba siya ng direction or ng speed or titigil siya. Okay? Ayan. So for you to be able to practice solving the escape velocity, I suggest that you solve here, ayan, on your own. Although in our synchronous class, I believe we will be able to solve some of it. Using this equation, you just have to solve for the escape velocity for each of these planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, using the radius of the object or the radius of the planet, as well as the mass of the planet. Okay? Ayan, let's compare the escape velocities of planets in our solar system. Notice that the more massive, kasi nga diba dependent sa mass ang escape velocity, pag mas massive yung planet, just like Jupiter, siya din yung may mas mataas na escape velocity. At ito yung consequence niya or yung implications niya. Ha? Kapag mas mataas yung mass ng object, again, mas mataas yung escape velocity niya, at ibig sabihin nun, mas mahirap mag-escape dun sa planet na yon. It is harder to escape the gravitational influence of more massive body. The more massive the object is, or the more massive the planet is, the harder it is for an object to escape its gravitational influence. And it is mostly dependent upon the anong tawag dyan, the masses of the planets. Alam naman natin that the biggest planet is Jupiter, and then the next one is Saturn, and notice that kung ano yung pagkakasunod-sunod ng kanilang mga mass, that is also the pagkakasunod-sunod or the ranking of their escape velocities. It also means that the greater the escape velocity, the more energy is required for that object to be able to escape the gravitational influence of the planet. Again, kapag mas massive yung planet natin, mas malaking kinetic energy dapat yung kailangan na isupply mo dun sa object para siya ay makawala sa gravitational influence ng planet na yon. Okay? So kung ikukumpara natin saan mas mahirap tumakas, sa Earth o sa Jupiter, syempre sa Jupiter kasi mas massive si Jupiter, so mas malaki yung kanyang gravitational force na i-exert doon sa object, so mas mahirap na mag-escape sa kanya. Mas mataas ang escape velocity and mas marami kang energy na kailangan i-supply para maabot yung escape velocity ng object na yon. Now, why is it important for us humans to explore outer space? Wala namang kinalaman sa atin yung mga planeta, yung mga stars. Ano naman kung ganito sila mag-behave? Ano naman kung ganito ang picture ng black hole? Ano naman kung mapicturean natin ang itsura ng Jupiter sa pamamagitan ng Juno space probe? Bakit kailangan pa natin ng mga Sputnik 1, ng mga probe na dinadala sa ibang bansa tuloy, sa ibang planeta, ayan. For you to be able to know that, ito hindi ko na i-discuss at hindi ko na ipapakita dito, please watch the video indicated in this link, which is also going to be provided using your Canvas account in the YouTube lecture links. That's all for the Newton's law of universal gravitation part 2. Thank you for listening and see you again on the next video, which will be about Kepler's law or Kepler's laws pala kasi tatlo yun, Kepler's laws of planetary motion. Ay, wait lang. Bagay natin ang cursor.